Okay, so for the most part, the numbers should be fairly easy to work with. You know, they won't be huge numbers that'll be scary to do without a calculator. These might even be a bit ambitious. These are examples that I picked. If this was a test, it'd be smaller. So anyway, you don't worry about the fact. It should be fairly obvious if there's no calculator. Okay, determine the value of each without using a calculator. So this is more typical of what you'd see. So we're going to rely on what we know about exponents and things.
3.
So the first one's easy, right? 3 cubed is 27. So that's right. The answer is 3. But how do we do the next one? How did you know that? It's the square root of 5. Can you do the square root of 5 in your head? How did you know?
Well, we learned it last year. It's the, what do you call it? A root is a half exponent.
Yeah, root's a half exponent. So if this is what you think of in your head, this question is asking, okay, now wait for it, what exponent of 5 is 5 to the 1/2? The answer is right there. What exponent of 5 is 5 to the 1/2? It's 1/2, because the exponent is right there. It's actually showing you what the exponent is. So the answer for this question is a half. So see if you can work out how to do the next one. It's going to take a little bit of jumbling around, but see if you can come up with what's the log base 2 of the cube root of 64. So some people seem to have an answer awfully quickly. Ming, how did you know that answer so quick?
The cube root of 64 is 4.
Okay, so that's one way we could rewrite this. We could rewrite it as log base 2 of 4. And then I know that's a fair question even before 1030. That is an easy one, right? 2 times 2 is 4. So 2 squared, that's the answer. Okay. So one of the goals that you'll be working towards is solving log equations. That's probably like an all-time favorite pastime of grade 12 students.
Oh my god.
But this is just to give you an introduction of some of the ways now that you can start solving these equations. So for example, you might be able to do it directly. You might be able to just tell me, what's x in the first example?
100.
100, yeah. So if you're good with logs, x is equal to 100. What if you weren't good with logs? What could you do? What if you're like, oh, I hate logarithms?
10 to the second power.
Yeah, turn it into an exponential. If you don't like logs, then work with exponents. Okay? So that's your strategy right now. If you can do it with a logarithm directly, go for it. If you can't, change it to an exponent. Okay? So you can use your calculator on these ones. What do you think? What's the second one going to be?
256.
It's going to be 256. So again, it would be rewritten. So x equals 256. Okay. What about log base x of 256 equals 8?
3.
2.
Well,
No, wait.
what could we do here maybe to help ourselves out?
256.
Well, I know you're shouting out 2 because you know the answer, but how could we actually solve it? Because some people don't necessarily see it right away, but how could we rearrange and solve this? So it sounds like you've already jumped one step in the equation. You're correct. This is x to the 8 is 256. So x is the 8th root of 256. Or, of course, we could write that as 256 to the 1/8. That way you could do it in your calculator. And now you have a number, x equals 2. What about the next one? Yeah, 4 zeros and then a 1.
1. No, wait, 5. No, wait. 1. 10. 10. 10. No, wait. What?
Stop guessing and checking. Just get it in your calculator. So how do we do? Anybody think they got it? John, you look like you're... Nope. Well, I'll start you off again. If you don't like logarithms, don't use logarithms. Okay.
What is that? 10, 1 to the negative fifth power? Or is it... in scientific notation.
Oh, you want to write in scientific
No,
notation?
it's my calculator.
Oh, okay. Well, if this is where we're at right now, what we could do is we could flip both sides. See, there's a negative exponent here. So one thing we could do is we could go x to the 5th equals 1 over. So what do you get? Sorry, 5?
I know.
1, so that's
Jeez.
2, 3, 4, 5. Right?
Yeah, I guess so.
So x equals to 10. I should really get my, let's just double check here. Okay, so it is, I'm okay. Okay, so there's other ways we could solve for these two. For example, this first one, if you don't like logs, don't use logs. This will be 5 to the 5th is x plus 3. So in my calculator, 5 to the 5th is 3125. So that tells me that x has got to be 3122. Okay, what's the next value for x? Okay, so if you rewrite this, you've got 7 cubed is 3x plus 1. 343 is 3x plus 1. So 342 is 3x. X is, oops, technical difficulties. There we go. X equals 114. Okay. So let's just take a straw poll here on a scale of 1 to 10. Or let's just do 5. You only have 5 fingers on one hand. 5 being the worst thing that we've done so far. How are we doing with logs? 5, okay. 2s? Okay. Okay, so fair enough. We're about medium. That's about where we should be here. So here's a couple to practice. Try this with a neighbor. Double check your answers with each other. See how you're doing. Okay, so if we double check this, 3 cubed is 2x minus 1. So 27 is, oops, 2x minus 1. So x is 14. Okay, can I just see show of hands? Do we get that? Awesome. Okay, so one more. 2 to the 5th is 5x plus 2. 32 is 5x plus 2. So 30 is 5x. X is 6. Okay, so that's basically what we're going to play with for the definition for today. We're going to take a look at a couple other definitions and some things that are handy to know about logs. So let's look at some identities. Okay, let's start with the first row right here. Okay, what do you think? Log 10 of 10 is?
1.
1. Genius. Log 5 of 5?
1.
Pure genius. Look at that. You guys are good with your 5s. How about, okay, this is a tough one. 23, yeah, it's 1. Okay. So if you have any number in that base and you take its log, it's just going to equal 1. That's the pattern I was trying to show you there. So even though it's letters, if it was log x of x, you can safely say that's 1, no matter what the value of x was. So sometimes we can simplify stuff by knowing that little rule. Okay, let's take a look at the next one. Can anybody figure out how is 10 connected to 1?
0.
Oh, look at that. Coffee's kicking in. 5 connected to 1? Okay, and the tough one again, 23,846.
0.
Yeah, it is also 0. So any number that you have, if you want to know how is it connected to 1, it's always going to be 0. The exponent would be 0. Okay, so again, we can cut some stuff down and do some simplifying if those appear in our work.
What about 0?
What about 0?
Log 0 of 1.
Log in base 0. That's a good question. So I'm going to have to stop this part of it for now.